Welcome back, quantum adventurers. All right, so we've met the qubits, we've seen their superpower of superposition, and we've witnessed that wild magic of entanglement. But that brings us to the next big question. How do these incredible machines actually, get the work done?
Right. If qubits are fantastic dancers, who's the choreographer? What is it that tells them how to move, when to spin, and how to team up to solve some of the world's toughest problems? Well, let's pull back that curtain and find out.
Okay, so let's dive right in. To get from a qubit just kind of hanging out to a qubit actually calculating something, we have to guide it. And in the world of computing, that guidance comes from something we call a gate. And you can see the difference right here, and it is a huge difference. On the left, classical gates are basically just light switches. Super simple. They take in zeros and ones, and they give you a totally predictable 0 or 1. But quantum gates over on the right, they are something else entirely. They're not just on-off switches. They're dynamic, powerful tools that literally rotate, twist, and transform the very state of a qubit. Honestly, the best way to think about it is this. Each and every quantum gate is a specific dance move. It's a precise instruction that tells a qubit exactly how to spin, how to change, and how to enter that mind-bending world of quantum possibilities. And of course, when you string these moves together, you get a whole performance. Now, to understand the whole dance, you don't need to learn every single step. We're just going to focus on two of the most famous and, frankly, most important dance steps in the entire quantum choreography. Let's get into it. First up, we've got the legendary Hadamard Gate. We just call it the H gate for short, and its job is pure quantum magic. This is the move that puts a qubit into superposition. It takes a qubit that's just a plain old 0 or a 1 and pushes it into that incredible state where it's both at the exact same time. If the Hadamard Gate had a motto, this would absolutely be it. It is the ultimate maybe. By putting qubits into superposition, it's basically telling the computer, hey, explore all the possible paths at once. And that is the secret to its incredible power. And you can see how it works right here. It's pretty cool. Notice how the qubit starts on the left as a simple, predictable 0. Then it passes through that Hadamard gate, and bam! It comes out the other side as this perfectly balanced mix of both 0 and 1. It's now ready to explore every single possibility. Okay, on to our next big dance step, the C0 gate. It stands for controlled not, but I like to call it the teamwork gate. Why? Because its entire purpose is to create that spooky friendship we talked about, the one we know as entanglement between two qubits. The logic here is actually surprisingly simple. You've got a partner qubit and a target qubit. It's an if-then deal. If the partner qubit is a 0, then nothing happens to the target. It stays the same. But if the partner qubit is a 1, the C0 gate flips the target state. It's that simple connection that forges the incredibly powerful link of entanglement. So, we have our individual dance moves, the Hadamard Gate for superposition, the C0 gate for entanglement. But a real dance isn't just one move, right? It's a full performance. And that's where quantum circuits come into the picture. So, a quantum circuit, just think of it like a piece of sheet music for a symphony or a choreographer's master plan. It's the blueprint that lays out the exact sequence of gates, telling our qubits precisely how to dance to solve a specific problem. And here's a super simple example of what that choreography might look like. First, you start with a Hadamard gate to open up all the possibilities. Then, you might use a C0 gate to link the fates of two qubits together. And finally, after the whole dance is done, you take a measurement to see the final pose. And this brings us to the grand finale. This is the big moment. The qubits have danced, they've explored this vast landscape of possibilities, but how do we get a single, useful answer out of all that amazing complexity? This is where the real magic happens. Thanks to superposition and entanglement, the qubits explore a massive number of solutions all at the same time. Get this, with just 10 qubits, that's over 1,000 possible paths explored in a single go. That right there, that is the quantum advantage. But the very instant we measure them, that entire cloud of probability just collapses. All those 1,000+ possibilities, they instantly resolve into one single clear answer. And here's the clever part. By designing the right choreography, the right circuit, scientists can actually guide that collapse, making it way more likely to land on the correct solution to the problem.
Now, it's really easy to think of all this as just abstract magic, some beautiful theory. But this dance, it's happening inside real physical devices as we speak. So let's connect all this to the incredible machines that actually make it possible.
And yeah, they look absolutely nothing like the laptop or phone you're using right now. I love this description. They really do look like these intricate golden chandeliers. And they have to be kept in these crazy cryogenic chambers, cooled to temperatures literally colder than deep space, all to protect the super fragile quantum states of the qubits inside.
So, who is building these things? Well, you've got the huge players you'd expect, like IBM and Google, but there's also this amazing, vibrant ecosystem of startups popping up all over the world, and every single one of them is pushing the boundaries of what we thought was possible. This isn't sci-fi, folks. It is happening now.
Okay, so let's bring it all home. Let's summarize the incredible performance that we've just witnessed. How do all these pieces fit together to create what is probably the greatest computation show in the entire universe?
It really all comes down to this. The qubits are our talented dancers. The quantum gates are the choreography that tells them what to do. And when they all perform together in a circuit, they create nothing short of a computational masterpiece.
It truly is the place where the rigorous, beautiful logic of mathematics meets something that for all the world just feels like pure magic. So, we've seen how they work, but the next big question is, what can they actually do? Well, in our next explainer, we're going to look at how these amazing machines are already starting to change our world, from designing brand new medicines to creating unimaginable artificial intelligence. I'll see you then.